Good morning, one and all. I'm Mr. B. Safekar. On behalf of AISSMS Polytechnic Pune, welcome all of you in today's session, Revision of Survey Concepts, Conventional Introduction to Modern Leveling Instruments. Today, we have a great personality for this session, Dr. Madhukar Jadhav, Professor, Sanjivani Engineering College, Kopargaon. Good morning, sir.
Good
Sir
morning.
has started his career in teaching field in 1990 from Amrutvani College of Engineering, Sangamner, and today he is working as a professor, Civil Engineering Department, Sanjivani College of Engineering, Kopargaon from 2011. During this 30 years experience in teaching, Sir taught various subjects of civil engineering. Sir made a mark in the field of education, has attended more than 29 workshops, seminars on various civil engineering and other topics at university level, state level, national level, and international level. Sir has organized various technical events such as Techno-Amrut national level paper presentation every year since 2004. 2 days national level workshop on environmental pollution and preventive measures. Techno Sanjivani 2015 and 2016 2 days state level project exhibition for final year students. Sir published more than 20 papers in various international journals and presented more than 10 papers in national and international conferences. Sir is the author of the textbook of Advanced Surveying and Building Materials and Construction. Sir pitched a grant from AICTE under the Modrop scheme for rupees 5 lakh for the development of surveying laboratory in 1998, rupees 6 lakh for the development of environmental engineering laboratory in 2003, rupees 6 lakh for the development of transportation engineering laboratory in 2011, and rupees 14 lakh 10,000 for the development of modernization of environmental engineering laboratory in 2017. Great achievement, sir, and it is very useful for the students. Now I request Jadhav sir to start the session.
Thank you for wonderful introduction. Whether am I audible?
Yes, sir.
Slides are visible?
Yes, sir.
Okay. So first of all, I am very much thankful to Principal AISMS Polytechnic Pune, Professor Giram sir, Head of the Department Amrutkar sir, and his team for giving me opportunity to deliver the lecture in one of the most important FDP, that is National Level Induction Refreshers Program on Advanced Surveying Instruments and Technique, organized by AISMS Polytechnic Pune, and this program is sponsored by AICTE and ISTE. This program will run between 14th December to 19th December 2020. So in this program, I am going to deliver the first session regarding revision of survey concept, conventional distance and direction measuring instruments, and introduction to modern leveling instruments. I am Professor Madhukar Jadhav, Department of Civil Engineering, Sanjivani College of Engineering, Kopargaon. Welcome you for this particular session. So without wasting time, I will start directly the session. Friends, survey is one of the important subjects as far as civil engineering is concerned. As we know, in civil engineering, there are various subjects, and among all these subjects, survey is a basic subject and one of the important subjects as far as different civil engineering projects are concerned. Without surveying, without measurement, there is not possible to go for the construction of that particular project, and hence not only in civil engineering, but in other engineering also, the survey, or we can say measurements, plays important role. So starting with the introduction, that is definition of surveying. Surveying is the art of determining relative positions of different points or objects on the surface of Earth by measuring horizontal distances between them. And this measurement is done for the preparation of map or plan of that particular area. So surveying is nothing but it is the measurement taken in the horizontal plane alone. Then another concept is the leveling. Leveling is the art of determining the relative vertical distances of different points on the surface of Earth. Therefore, leveling is the measurement taken only in the vertical plane. Next, object of surveying. Now, these object of surveying are very much important as far as different applications of surveying are concerned. Object or purpose of surveying is to prepare map or plan of that particular area. The map is drawn to suitable scale. Map shows the natural features of a particular area such as towns, villages, rivers, hills, valleys, forests, and so many other objects which are available in that particular area. Also, map can include the details of different engineering works such as roadways, railways, canals, dams, and other civil engineering projects. Then, uses of surveying, or we can say applications of surveying. In civil engineering, not only in civil engineering, but in engineering field, this surveying plays important role, and there are various applications of this particular surveying. So first application is to prepare topographical map which shows the hills, valleys, rivers, villages, towns, forest, etc. of a particular area. So by doing the area in a particular area, we can plot or we can show the details of hills, valleys, rivers, and so many other parameters or objects which are present in that particular area. Second application is to prepare the cadastral map showing the details of boundaries of field, houses, and other properties which are existing in that particular area. Third application is to prepare an engineering map showing the details of engineering works such as roadways, railways, reservoir, canals, sewers, and so many other. Next application is to prepare military maps Next application is to prepare a military map showing the roadways, railways, which are very much important for the military purpose. Also, such map shows the different strategic points of importance for the defense of a particular country. The next application is to prepare contour map to determine the capacity of the reservoir and to find out the best possible route, maybe for roadway or maybe for railway or also for the canals and so many other civil engineering projects. Next application is to prepare geological maps showing the areas including the underground resources, or we can say underground minerals which are existing below the ground. The next application is to prepare an archaeological maps showing the places of ancient importance which are exist in particular area. So these are the various applications of surveying which are used for different applications in the civil engineering. Next important part of surveying is principles of surveying. So principles of surveying are very much important as far as surveying is concerned. In surveying, there are two important principles. One is to work from whole to the part, and second one, to locate a new station by at least two measurements, maybe linear measurement or angular measurement from a fixed reference point or fixed reference line. Now, these principles we will see in short one by one. So first one, to work from whole to the part. So according to this principle, the whole area is enclosed by important points, called as control stations, and main survey lines called as control lines. After that, this area is divided into number of parts by forming well-conditioned triangles. And after that, measurement of main survey line and measurement of whatever we have formed is same or take. And accurate instruments, we can say. And this is done to prevent the accumulation of error. During this procedure, if there is any error in the measurement of any side of the triangle, then it will not affect the whole work. This error can always be detected and eliminated to the part. But if we of expansion, error will become absolutely why to locate a new state.
Sir, Jadhav sir, sorry for interrupt. Audio is break. Hello. Sir, are you mute? Sir, your audio is muted. Audible now.
Hello. Am I audible? Hello.
No, sir.
Hello.
Yes, sir. Yes. Now audible. Yes, sir.
A new station by at least two measurements. So, as per this principle, a new station should be fixed by measurement from two reference points. So, for example, here we want to locate the position of this R. Then, to locate the position of R, these are the two reference points P and Q. So, if distance PR and QR is known, we can fix up the new station R. Here, we are taken both linear measurements. Another example is if two angular measurements are known, alpha and beta, from P and Q, we can fix up the position of new station R. And similarly, these are the other techniques to locate the new station. So this is about important principles of Then next one is classification of surveying. Whatever the different types of survey are there, we can classify survey mainly into two categories. So first category is the primary classification, and second classification is called as secondary classification. So these classifications we will see one by one. First of all, primary classification. So as per the primary classification, we can classify the survey into plain surveying and the geodetic surveying. So we will see these one by one. First, plain surveying. In plain surveying, the curvature of earth is not taken into account. And this is because plain surveying is carried out over a small area. The area under consideration in case of plain surveying is small. So the surface of earth is considered as a plain one. And in such surveying, line joining any two points is considered as a straight line. This plain surveying is considered by the state government agencies, maybe PWD, irrigation department. And this plain surveying is done when the area is less than 250 square kilometer. So generally for the survey of highways, roadways, canals, this type of survey is done, that is plain surveying. Then next one is the geodetic surveying. In geodetic surveying, the curvature of earth is taken into consideration, and this is extended over the large area. Means when we want to do the survey for large area, we have to go for geodetic surveying. In case of geodetic surveying, line joining any two points is considered as a curved line, and the triangle formed by joining any 3 points is considered as spherical triangle. And hence, the geodetic survey is conducted when the area exceeds 250 square kilometer. And generally, this type of survey is performed by Survey Department of India. So this is the main classification of surveying, that is, as per the primary classification, geodetic surveying and the plain surveying. Then next one, secondary classification. Now, as per the secondary classification, we can classify the survey into different classes. So first one, based upon instrument used for the survey. So when we are using the chain for surveying, that survey is called as chain surveying. When we are using the compass, then that particular survey is called as compass surveying. So in this type of classification, the name of that instrument is given to that particular survey. So chain survey, compass survey, plane table survey, theodolite survey, tachometric survey, and the photographic survey. So based upon instrument used for the survey. Next one, based upon method of surveying. So as per this classification, we can classify the survey into triangulation survey and the traverse survey. So as we know, in case of triangulation survey, we have to divide that area into number of triangles. While in case of traverse survey, depending upon the project for which we are doing the survey, the traverse may be open traverse or it may be closed traverse. Then next classification, based upon the purpose of survey. So based upon the purpose of survey, survey can be classified as engineering survey, mine survey, and the military survey. And the last one is the based upon nature of survey field. So as per this classification, we can classify the survey into land surveying, marine surveying, city surveying, cadastral surveying, topographical surveying, and hydrographical surveying. So this is all about classification of surveying. Then next one, different terms used in surveying. So whatever the different terms which are used in surveying, that terms I am going to discuss in short. First of all, ranging. So when we want to measure the distances between any 2 points, in that case, we are using chain or tape for the measurement of distances. And depending upon the distance between first point and the last point, if the distance between the first and last point is more than one chain length or more than one tape length, in that case, we have to fix up intermediate points. So the process of fixing up intermediate points between two endpoints of a survey line is called as a ranging of a survey line or simply ranging. For ranging purpose, we have to use ranging rod, we have to use chain or tape, and we have to use arrows. The next one is the chaining. So chaining is the common method of measurement of distances. So distances measured in the field either with the help of chain or tape is called as chaining. Then for measurement of distances, we can use tape or we can use chain. So generally, metric chains are used for the measurement of distances, and these metric chains are available in the length of 20 meter and 30 meter. And these chains are made up of 100 to 150 links of 20 centimeter or 30 centimeter in length. And these links are made up of mild steel wires of 2 mm diameter. Then there are different types of tapes which are used for the accurate measurement of different survey lines. And these tapes may be made from linen or cloth, may be made for oven metallic tape or steel tape, or maybe synthetic tape or NVAR tape. Next one, traverse. So traverse is nothing but it is a frame formed by series of connected straight lines. So this traverse may be of two types depending upon the type of survey. One is called as open traverse and second one is called as a closed traverse. So ABCD is this open traverse, and mainly for the survey of roadway, railway, canals, sewer line, we are doing the survey by means of open traverse. While survey of dams and for other survey, we are doing the survey in the form of a closed traverse. Then depending upon the instrument used, there are different types of traverse. So these traverse are called as chain traversing when we are using the chain for traversing purpose, compass traversing, plane table traversing, and the theodolite traversing. So this is the sketch of chaining and offsetting which is used for doing the survey in particular area. So as we have seen in principles of surveying, so this is the area to be surveyed, and first of all these are the stations, or we can call these are the main stations, these are the main survey line, and by connecting these main stations we can form one baseline, and then we can do the survey, we can set the offset, we can measure the different distances, and then finally we can set one check line, and with the help of this check line we can check our survey which we have performed. Next one is the offset. So offset is nothing but it is a lateral measurement taken from an object to the chain line or survey line. So there are two types of offset. One is called as perpendicular offset and other is called as oblique offset. So in this figure, this is the chain line, or you can say survey line, and this is the object. So from this object, when an offset is taken exactly at 90 degree, then this is called as perpendicular object. Sorry, perpendicular offset. And when we take the offset at any angle other than 90 degree, that is called as oblique offsets. So depending upon the requirement, we have to take either perpendicular offset or oblique offset from the object on a given chain line or survey line. In case of surveying, plan or map is the graphical representation. So whatever the measurement which we are doing, with that particular measurement, we are plotting the map or plan with a suitable scale. And this particular representation or plotting is called as plan if the scale is small, and is called as map when the scale is large. Okay, so scale of a map is the ratio of distance on the map to the corresponding distance on the ground, or it is the distance on the plan to the corresponding distance on. Then the important thing in the scale is the representative fraction. Whatever the scale of a map or plan, that we are always converting to representative fraction, that is called as RF. So RF is nothing but it is a ratio of distance on map or plan or drawing to the corresponding distance on the ground, and both the distances are expressed in the same unit, and hence representative fraction RF is equal to length of the object on the drawing to the actual length of the object on ground. And whatever the scale or RF which we are writing, it is in the representative fraction form. Next one is the classification of scale. So there are different types of scale, or we can say we can classify the scale depending upon the range of the scale. So first scale is called as large scale. So when the scale is between say 1:100 to 1:10,000, this particular scale is called as large scale, and the scale is mainly used for plans. When the scale is between 1:50,000 to 1:20 lakh, then that scale is known as medium scale, and this particular scale is mainly used for plotting of map of districts or states. And third type of scale called as small scale. So when scale is more than 1:20 lakhs, then this particular scale is called as small scale, and this small scale is mainly used for the map of country or map of world or map of a galaxy. So this is all about the important terms which are used in surveying. Next one, in short, I am going to discuss regarding the different types of surveying. So first one, compass surveying. So compass surveying is the branch of surveying in which survey is done with the help of instrument called as prismatic compass or simply a compass. And in this survey, for doing the survey, angular measurement is done, and along with the angular measurement, we can measure the distances with the help of chain or tape. And the instrument which is used for this particular survey is called as prismatic survey. So the name for this instrument is given as a prismatic compass because in this there is a prism which is used for observation of bearings, or we can say angle, more accurately. Okay, so compass surveying is used in following circumstances, particularly when the area to be surveyed is large. Second one, if the plot for surveying has large number of obstacles and undulating area is there. And in such area, it is very difficult to go for the chaining. Then, in such situation, we have to go for compass surveying. Next one, if there is a time limit for the surveying, then compass surveying is usually adopted. Generally, hello,
Yes, audible. Hello. Hello, sir.
hello.
Yes, sir. Yes, sir. Hello.
Actually, मी पीसीवर
Yes,
बसलो
sir.
होतो त्याची पॉवर गेली.
हा. ओके ओके. मग परत आम्ही थांबतो तोपर्यंत रिस्टार्ट करेपर्यंत. सर सर जाधव सर.
हॅलो.
जाधव.
हा,
जाधव सर येतोय आवाज?
हो, आवाज येतो.
तुम्ही मोबाईल वरनं करणार आहे का? हो.
हा,
मग कसं
मोबाईल
करणार
वर.
पुढे?
हॅलो.
पीपीटी मग शेअर करू का आम्ही? पीपीटी शेअर
हा,
करू?
हो, तुम्ही पीपीटी शेअर करा.
ओके. पावर केली आहे. सिमरन पीपीटी शेअर करा. हा 5 मिनिटात सुरू करूया परत.
हो हो हो
तुम्ही
हो
मोबाईलवर जॉईन आहेत का तुम्ही? ओके. 2च फील्ड फक्त. ओके.
हो हो आहे जॉईन मी मोबाईलवर.
मग हा 2च मिनिटं सर.
हो हो हो. Is graduated from 0 to 360-degree clockwise, and the graduations are started from south end of the needle. And see how the graduations are written on this particular ring. 0 is placed at south end, 90 degree is placed at west, 180 degree is placed at north, and 270 degree is placed at east. And the degree in the prismatic compass is either divided into half degree or it may be divided into 20 minutes. And depending upon that, the least count of that particular prismatic compass is decided. Next slide, please. Then, in case of prismatic compass, or when we want to use the prismatic compass for surveying purpose, we have to do the temporary adjustment. And the different temporary adjustment which we have to perform includes fixing of the prismatic compass on the tripod stand, then centering of the prismatic compass, then leveling of the prismatic compass with the help of ball and socket arrangement, then sighting the object, and finally observation of a bearing. So all these temporary adjustments are need to be performed when we want to measure the bearing of any survey line or when we want to perform the survey with the help of prismatic compass. Next slide, please. Now, in case of compass survey, generally we are using two types of compass. One is called as prismatic compass and other one is called as surveyor's compass. So mostly today we are using the prismatic compass. So here there is a difference between the prismatic compass and surveyor's compass is given. So first point of difference is, in case of surveyor's compass, the needle is of edge bar type and also acts as an index. While in case of prismatic compass, the needle is broad needle type but does not act as an index. second point of comparison is the graduated ring is attached to the box and not to the needle in case of surveyor's compass, while in case of prismatic compass, the graduated ring is attached with the needle, or you can say with the magnetic needle. Third point of comparison is the graduation in case of surveyor's compass are in quadrantal system, and hence the value of the bearing varies from 0 to 90 degree only, while in case of prismatic compass the readings vary or graduations are in whole circle bearing system, and hence the bearing varies from 0 degree to 360 degree. Next comparison is the bearings are taken directly seen through the top of the glass in case of surveyor's compass, while in case of prismatic compass, the readings are taken with the help of prism provided at the eye slit of the prismatic compass. Next comparison is sighting and reading cannot be done simultaneously in case of surveyor's compass, while in case of prismatic compass, both can be done simultaneously. And the last comparison is the instrument cannot be used without tripod in case of surveyor's compass, while in case of prismatic compass, the instrument can be used with tripod or without tripod. The next slide, please. Comparison of whole circle bearing and the quadrantal bearing. As we know, for measuring the whole circle bearing, we are using the prismatic compass, while for measuring the quadrantal bearing, we are using the surveyor's compass. So, the comparison is the horizontal angle made by any survey line with magnetic north in clockwise direction is called as whole circle bearing, while the horizontal angle made by any survey line with north or south is called as quadrantal bearing, or it is also known as reduced bearing. Next comparison is the whole circle bearing is always measured clockwise with reference to north direction, while in case of quadrantal bearing, the bearing can be measured either clockwise or anti-clockwise, whichever is nearer to that particular line. Then the third point of comparison is the value of the whole circle bearing varies from 0 to 360 degree, while the value of reduced bearing varies from 0 to 90 degree. And the examples of whole circle bearing, that is 20 degree when the line is in first quadrant, maybe 121 degree when the line is in second quadrant, maybe 245 degree when the line is in third quadrant, maybe 350 degree when the line is in fourth quadrant, while the quadrantal bearings are N26 degree E, S65 degree W, or N10 degree W. So this is a comparison between whole circle bearing and the quadrantal bearing. Next slide, please. So in this particular sketch, how the whole circle bearing is measured is shown. That is, whole circle bearing is always measured from north up to that particular line, while the quadrantal bearing is measured either with respect to north or with respect to south, whichever is nearer to that particular line. So in second sketch, the reduced bearing is shown. Next slide, please. So here the whole circle bearings are shown depending upon the position of line. If the line is in first quadrant, the angle θ1 is the whole circle bearing. When the line is in second quadrant, θ2 is the whole circle bearing. When the line is in third quadrant, θ3 is the whole circle bearing. And when the line is in fourth quadrant, θ4 is the whole circle bearing of that particular line. Next slide, please. So here the quadrantal bearings of different lines depending upon the position of lines are shown. Next slide, please. So this is the table. From this particular table, we can convert the whole circle bearing to quadrantal bearing form or quadrantal bearing to whole circle form, depending upon on which that particular line falls. So this is the rule for conversion purpose. For first quadrant, whole circle bearing and quadrantal bearing are one and the same. For second quadrant, quadrantal bearing is equal to 180 minus whole circle bearing. For the third quadrant, reduced bearing or quadrantal bearing is equal to whole circle bearing minus 180 degree. And for the fourth quadrant, reduced bearing or quadrantal bearing is equal to 360 degree minus whole circle bearing. Next slide, please. Fore bearing and back bearing. So this particular concept plays very important role as far as prismatic compass survey is concerned. So fore bearing is nothing but when we are measuring the bearing of survey line in the direction of progress of that particular survey line is called as fore bearing. So here AB is the survey line. So when we measure the bearing from A towards B, that bearing is called as fore bearing of a survey line. And when we measure the bearing from B towards A, so this bearing or this angle is called as back bearing of a survey line. And as per the trigonometry, fore bearing and back bearing always differ by 180 degree. Hence, we can write the formula: back bearing of a survey line is equal to fore bearing plus or minus 180 degree. So this is very important formula. So once fore bearing is known, we can find out its back bearing, and if the back bearing is known, we can find out its fore bearing. Next slide, please. In case of prismatic compass survey, the local attraction plays very important role. So depending upon the local attraction, whatever the readings which we are taking, that may be corrected one or incorrect one. So see, while performing the survey, the magnetic needle sometimes get disturbed from its normal position under the influence of some attractive forces. So such influencing forces is called as local attraction, and due to that particular influencing forces, there may be the error in the observed fore and back bearing of the line, and due to that, the observed fore bearing and back bearing will not be the correct one, and hence the difference in fore bearing and back bearing will not also be the correct one. And hence, when we want to go for the plotting, we have to find out the local attraction at that particular station, and then whatever the observed fore bearing and back bearing of different lines, that we have to correct by applying the local attraction to that particular points or stations. Then next one. Next slide, please. Declination. So this concept of declination is also one of the important concepts as far as compass surveying is concerned. So the horizontal angle between magnetic meridian and the true meridian is known as magnetic declination. So depending upon the position of this magnetic north, there may be a magnetic declination. It may be towards east side or it may be towards west side. And when we want to find out the true bearing of a survey line, we have to find out the true bearing by using this particular formula, that is, true bearing of a survey line is equal to magnetic bearing of a survey line plus or minus magnetic declination. And we have to use plus sign if the declination is towards east, and we have to use negative sign when the declination is towards west. Next slide, please. So this is all about the prismatic compass in short. Then second important type of surveying is the plane table surveying. And this is most important survey as far as survey in the rural area is concerned. So plain table survey is a simple, convenient and quick method of surveying in which plotting and fieldwork is done simultaneously. And therefore, this survey did not require fieldwork for recording purpose. And this plain table survey is mainly suitable for filling interior details when traversing is done by theodolite survey. Now, this plain table survey has one of the important principle. The principle on which plain table survey depends is the parallelism. That is, the rays drawn from station to the object on the paper are parallel to the line from the station to the object on the ground. So on this particular principle, all the methods of plain table survey are working. Next slide, please. Different accessories which are used in plain table survey. So plain table or drawing board. So this particular plain table has a size of 750 mm to 600 mm and it is made from well seasoned teak wood or pine wood, and top of this table is made plain, and at the bottom of this particular table there is an arrangement to fix this drawing board or plain table on the tripod stand with the help of wing nut. Then another accessory is called as spirit level for leveling of the table. Next slide, please. Next slide, please. Alidade. So alidade plays very important role as far as plain table survey is concerned. And in case of plain table survey, there are two types of alidade. One is called as plain alidade and another one is called as a telescopic alidade. So when the extent of survey is small, in that case, we are using this plain alidade. And when survey has more length, in that case, telescopic alidade is used. In case of plain alidade, there are two vanes. One is called as object vane and another one is called as eye vane. And with the help of these two vanes, we can sight the different objects while performing the plain table survey. Next slide, please. The next accessory which is used with plain table survey is the trough compass. Mainly for marking the north direction, we are using this trough compass in which there is a magnetic needle. Then next important accessory which is used in plain table survey is called as U fork or plumbing fork. As the shape of this is like a U letter in English, that's why it is called as U fork or plumbing fork. This particular U fork or plumbing fork is mainly used for transferring ground point onto the drawing sheet or the point which is already exists on the drawing sheet to transfer that on the ground point. So U fork is very much important as far as transferring the off point from ground to the sheet or from sheet to the ground is concerned. Next slide, please. Uses of plain table survey. A compass survey cannot be carried out in industrial areas of the town because in industrial area there are steel structures, and due to that steel structure there may be chances of, we can say, local attraction in the observed reading, and hence in such a area plain table is more suitable. Also, plain table can be used for preparing small and medium scale map where the great accuracy is not required. Also, this plain table survey is speedy, easy, and we can say some accurate for doing the survey. Next, plane table can be used to plot the developed area on the previously plotted plan of an existing area. Next one. Next slide, please. Uses of Next slide, please. Uses of plane table survey that we have seen. Next, advantages and disadvantages.
Next slide again, advantages and disadvantages.
Advantages and disadvantages of plane table survey. Hello. Sapekar sir.
Yes sir. Yes sir. एकच मिनिट. पुढची स्लाइड घ्या ना, ऍडव्हान्टेजेस.
Yes.
नाही आली.
Advantages and disadvantages of plane table survey. First one, map of the area is plotted in the field itself, and that's why there is not necessity of field book, or you can say there is not necessity of any writing which is required in case of plane table survey. So field book is not required. Then correctness of this plotted work can be checked in the field itself. Then in the office, only finishing work of that particular drawing which we have plotted in the field can be done. Then this is suitable in magnetic areas where we cannot use the prismatic compass survey. Also, this survey is done within a short period of time, and also the labor force required for this survey is less in number. Then when the budget allotted for the survey is less, then in that particular case, we can use the plane table survey instead of, we can say, theodolite survey. Then it is a most suitable method for preparing the small scale map. Then this survey can be completed with rapidly, or we can say with a fast rate. And the last one, map can be prepared easily and does not require any great skill. Next slide, please. Disadvantages. So plane table is not suitable for work in wet climate, rainy season, and in places where high wind predominates. If the area to be surveyed is large, then frequent changes in the size of drawing sheets are required. So in such an area, it is not possible to perform the plane table survey. Then if the sun is bright, plotting may be difficult due to the strain on the eyes. Next one, it is not very accurate for large scale survey as compared to compass and theodolite survey. Another disadvantage is that the instrument and its accessories are heavy and cumbersome, and there may be chances of loss of any of the accessory of the plane table survey. And the last disadvantage, since the field loops are not maintained, it is inconvenient to calculate the quantities or to replot the survey to a different scale if required. So all these are the different disadvantages of the plane table survey. Next slide, please. Procedure for setting up of the plane table survey or plane table. So when we want to do the plane table survey, first of all, we have to select the station. After that, on the selected station, we have to set the plane table. Then we have to fix the plane table on the tripod stand. Then we have to level the table properly. Then we have to fix up the drawing sheet on the plane table. After that, we have to properly center the plane table on the given station. Then most important is the marking of north direction. And then depending upon the different stations, we have to go for the orientation of the plane table. That is, when plane table survey is to be conducted by connecting several stations, then after shifting the plane table, we have to do the orientation. And this orientation means we have to keep the table parallel to the line drawn from the previous station. Next one. Next slide, please. So orientation of the plane table can be done by two methods. One method is called as with the help of magnetic needle, and second one is by backsighting method. So I will go somewhat fast because time required is more for the presentation, and whatever the time left is very less. Next slide, please. Methods of plane table survey. So plane table survey can be performed by four methods. One is called as radiation method. Second one is called as intersection method. Third method is called as traversing method. And fourth method is called as resection method. So out of these, first two methods we will see in short. So radiation method first. So in case of radiation method, we have to select the station in such a way that the boundary points of the area can be seen from that particular station. For example, we have selected PA as a plane table station, and these are the boundary stations, maybe say A, B, C, D, E. So in this radiation methods, first of all, we have to set the table at point P, and we have to fix up the ranging rod at point A, B, C, D, E. And after setting the table at point P, we have to sight these points A, B, C, D, E with the help of LED. And then we have to measure the distances from this point P to the A, and that distances we have to plot with a suitable scale. And then we have to join the station A to B, B to C, C to D, D to E, and E to A. So after joining these, we will get the map or plan of that area by radiation method. Second method, next slide, please. Intersection method. Next slide, please. Now, in case of intersection method, we have to select number of stations depending upon the extent of the area. So, in case of intersection method, first of all, we have to set the table at a first station, and after leveling and centering, we have to fix up the drawing sheet, and then we have to mark station A on the drawing sheet, and from this we have to sight the second station, that is B. At the same time, we have to sight the last station, say for example E. And then again we have to sight the remaining stations, maybe C, D, and whatever the different stations are available in that particular area. And after that, we have to shift the table to point B. And after setting the table at point B, we have to orient the table maybe by backsighting method or maybe by magnetic needle method. And then again, we have to sight the different points. And by intersection of the rays from point A and rays from the point B, we will get the positions of different points, maybe C, maybe D, and maybe E. And then after joining these points on the drawing sheet, we will get the area of that particular points on the drawing sheet, maybe A, B, C, D, E. So in this method, only length of baseline we are measuring, and other points we are getting by the intersection of the rays from A point and the intersection of the ray from B point. So this particular method is called as we can say intersection method. Next slide, please. So this is the traversing method. I will not discuss. The next slide, please. Next slide. So we have seen compass surveying and the plane table survey. Next, we are going to study in short regarding leveling. So leveling is the branch of surveying which deals with finding the elevations of given points with respect to given or assumed datum, or process of determining the heights of one level relative to the another level is called as leveling. So we can define this leveling. Leveling is defined as an art of determining the relative heights of different points on, above, or below the surface of Earth. Hence, leveling is nothing but measurement in a vertical plane. Next slide, please. In leveling, datum plays very important role. So datum is nothing but it is any reference surface to which elevations are referred. The mean sea level is a convenient datum surface with respect to which elevations or heights are commonly measured. A datum plane or datum is an arbitrarily assumed level surface or line with respect to which levels of different surfaces are calculated. Now, when the Britishers have ruled our country, they have taken datum surface of sea level at Karachi. But after the independence, we have selected the mean sea level at Mumbai as the datum surface. Next slide, please. So mean sea level, it is an average level of the surface of one or more of earth bodies of water from which height such as altitudes or reduced levels of different points are measured. And so this mean sea level is very much important as far as benchmarks are concerned. Now, in the leveling, benchmark plays very important role. Benchmark is nothing but it is a fixed reference point of known elevation. And the leveling operation is always started from such points, and maybe leveling work can be end on the point of known elevation. Now, as we know, on every railway station, the Britishers have written the mean sea level to know the elevation of that particular junction, or to know the position of that particular station with respect to mean sea level. Next slide, please. Benchmarks. So benchmarks are plays very important role as far as leveling operations are concerned. There are 4 types of benchmark. One is called as GTS benchmark. Second one is the permanent benchmark. Third one is the arbitrary benchmark. And fourth one is the temporary benchmark. So depending upon the accuracy of the work, we have to select either GTS benchmark, permanent benchmark, arbitrary benchmark, or temporary benchmark. Now, these GTS benchmarks are established by the Survey Department of India, and they are established by the Survey Department of country throughout the country, and the values of these benchmarks are published in the catalog published by the Survey Department of the area. Next one, permanent benchmark. So these are the fixed points or marks established by the state government agencies, maybe public work department or maybe irrigation department. The reduced levels of these points are determined with reference to the GTS benchmarks, and the reduced levels are marked on permanent objects such as plinth of a building, parapet wall of a bridge, or culvert in that particular area. Then third type of benchmark is called as ABM. When small ordinary leveling work is to be carried out, or when the permanent benchmark is not nearby the place or area where the survey is to be carried out, then we have to start the leveling work from any prominent object in that particular area. Say, for example, plinth or step of a building. And such a chosen benchmark is called as arbitrary benchmark. Next, temporary benchmark. Next slide, please. Next slide, please. Temporary benchmark. The survey for large projects normally continues for a number of days. Hence, at the end of the days, when the leveling work for that particular day has completed or stopped, then any permanent object nearby is chosen on which the day's work is stopped, and on the next day, the leveling work is started from that particular object or point. So such an object or such a point is called as TBM, temporary benchmark. So this is all about the different types of benchmarks. Next slide, please. Important terms related to leveling. First term is line of collimation or line of sight. So this is nothing but line joining the intersection of crosshair of diaphragm to the optical center of the object glass and its continuation. This line is also known as line of sight. Next one, height of instrument. When instrument is properly leveled, the reduced level of the line of collimation is known as height of instrument, or we can call it as a HI. So HI is nothing but backside reading plus RL of benchmark. Next one is the backside reading. The first reading taken on a point of known elevation is known as backside reading, or after the change of instrument, whatever the reading taken is also called as backside reading. So in this figure, this is the benchmark. So first reading taken on the benchmark is known as backside reading. Then whatever the other readings are there called as intermediate sight reading. And the last reading taken from the first instrument is known as foresight reading. And after that, instrument is shifted to the second position. And then after leveling at a second position, we are taken on the reading called as a change point. That reading is also called as backside reading. Next slide, please. Next slide, please. Foresight reading, intermediate sight, and change point. After that, leveling. Now, for leveling purpose, we require level and leveling staff. So, the level is nothing but it is an optical instrument used to establish or verify points in the same horizontal plane, and this particular process is called as leveling. And this level is used with a leveling staff. Now, whatever the level which we are using has different parts. The most important part of level is the telescope, and this provides the horizontal line of sight. Then level also consists of leveling tube, and with the help of this, make the line of sight horizontal. Then the level is another important part is called as the leveling head. With the help of this leveling head, we can level the instrument. Then next important part of the level is tripod stand, and with the help of this tripod stand, we can fix up. Next slide. So this is a dumpy level. It consists of telescope, spirit level. This is the leveling head and the foot screw. This is the eyepiece, and this is the diaphragm, we can say, and this is the objective glass. Okay. Next slide. Again, these are the various parts of dumpy level: telescope, bubble tube, compass, vertical spindle, try badge, foot screws, leveling head, and the tripod stand. So these are the different parts explained in short. Next slide, please. Next slide. Next slide, please. Next slide. Next slide, please. So this is important. Classification of level or types of level. Leveling has been classified into different types depending upon the purpose for which it is carried out. So the different types of leveling, one is the simple level. So see, simple level is the basic form of leveling in which the leveling instrument is placed between the 2 points for which elevation difference is to be required. So in the sketch, this is the first point, this is the second point, and the instrument is set in between the two. And then after leveling the instrument, we can take the reading on the first stop, we can take the reading on the second stop, and just by subtracting the reading of the first stop from the second stop, we will get the level difference between the 2 points. So when the distance between the 2 points is less, in that case, we have to perform the leveling called as simple leveling. In case of simple leveling, we are not changing the instrument. Next slide, please. Differential leveling. So this differential leveling is performed when the distance between the 2 points is more. As shown in figure, first point and the last point, the distance is more. So in such cases, we have to go for the differential leveling. Next one, the difference of elevation between the first point and the last point is large. In that case also, we have to go for the differential leveling. Also, when there are more number of obstacles between the first point and the last point, in that case also, we have to go for the differential leveling. Also, in this particular process, number of intermediate stations are located, and the instrument is shifted from one station to another station to find out the level difference between the first point and the last point. So as shown in figure, instrument is set at first, then at second, at third, at fourth, and so on to reach up to the last point. And then finding out, we can say, elevations of different points, we can find out the level difference between the first point and the last point. And this particular type of leveling is called as differential leveling. Next slide, please. Fly leveling. When differential leveling is done in order to connect a benchmark to the starting point of the alignment of a leveling work of any project is called as fly leveling. And see, in case of fly leveling, we have to take only backside reading and foresight reading up to the last point of that particular survey. So see, in the figure, there is a benchmark. Then we have kept the staff on benchmark. We have taken the reading on the benchmark. Then we have hold the staff on the second point. We have taken the foresight on that particular point. Then we have shifted the level to change point, and from the change point, again we have taken the reading on the change point, and that reading is called as backside reading. So in this way, foresight, backside, foresight, backside, we have to take to reach up to the last point of the survey. And this particular leveling process is called as fly leveling. Next slide, please. Check leveling. So as the name given, this leveling is done for taking of the work which we have done. So fly leveling is done at the end of the day's work to connect the finishing point with the starting point on that particular day. And this particular leveling is known as check leveling. So in case of check leveling, what is done? We have to perform the fly leveling from last point up to the first point. So in this case, again, we have to take foresight reading, backside reading, foresight reading, backside reading, and we will have to reach up to the starting point of that particular leveling work. And if we get the same reduced level, what we have chosen or what is the level of the first point, then that particular leveling is called as check leveling. And if we get the same level, then whatever the work we have performed is correct one. And if there is a large difference, then we have to repeat that particular work. And this particular leveling is called as check leveling. Next slide, please. Profile leveling. So this profile leveling is one of the important leveling as far as different civil engineering projects are concerned. This leveling is also known as longitudinal sectioning. So this particular leveling process is performed to know the elevation of different points at measured interval along a fixed line. Now, in this particular profile leveling, the line may be taken as a center line of a roadway, railway, canal, or sewer, and to know the profile of that particular work is known as profile leveling. In this particular leveling, we have to take back intermediate site at regular intervals. And for that purpose, we have to shift the instrument depending upon the requirement. Next slide, please. Now, in this, we have to take the measured distance, and at that particular measured distance, we have to hold the staff, and then we have to take the reading. And whatever the data of distances and whatever the data of reading, that we have to fill up properly in the level feedbook page. Next. Am I audible? Hello, Tapekar sir. Hello. Previous slide.
Sir, audio is not clear. Hello? Hello? Sir, audio
Am I
clear
audible,
नहीं है.
sir?
Not
Hello,
audible.
sir.
Yes, yes, now, sir. Now audible.
Tapekar, sir.
Yes, sir.
Next slide,
Yes, sir.
please.
Yes, sir. Audible now.
Yeah,
Simran,
yeah.
next
Next
slide. Game.
slide. Next slide, please.
Yes, sir. Yes. Next game.
So this is the cross sectioning. When we want to know the nature of the level at a perpendicular to the center line of that particular project, that particular leveling is called as cross sectional leveling. Next slide, please. Reciprocal leveling. When we want to find out the level difference between the two endpoints on the bank of a river, in that particular case, we have to take the reading from the dumpy level on the staff held very near to the first bank and on the other bank. So such a type of leveling is called as reciprocal leveling. Next slide, please. This is the last type of leveling, that is trigonometrical leveling. So in case of trigonometrical leveling, to find out the elevations of different points, we have to use the leveling instrument and the leveling staff. So this particular type of leveling is called as trigonometrical leveling. So this is all about leveling. The next one is the auto level. So in case of auto level, there is a provision of tilt compensator. So with the help of tilt compensator, if the line of sight is slightly disturbed, so with the help of this particular tilt compensator, the line of sight may get automatically horizontal. And this is the beauty of, we can say, auto level. So auto level is one of the instrument which is used for fast taking the levels of different points, and even though there is a slight disturbance in the line of sight, it will get automatically horizontal. Next slide, please. Next slide. Advantages of auto level. So these are the advantages. Auto level is very easy to use. No adjustment of stop reading is required. The bubble can be adjusted from any side. The auto level has an internal compensator mechanism which automatically adjusts the line of sight. The measurement accuracy of auto level is large than the dumpy level. Auto level results are very accurate, and use of auto level saves the time while doing the leveling work. Next slide, please. Lesser level. So this is the another type of modern level which is used for leveling purpose. So laser level use the laser and amplified focused beam of light emitted from solid state device called as a diode. So as we know, the light entering light emitting diodes, also known as LEDs, are used in this particular laser level, and whatever the beam which is emitted from this level can be used for bisecting the stuff, and after bisecting, whatever the coded stuff is there, it is directly visible on the we can say display of this particular auto level. Next slide, please. So this particular laser level can be used for different purposes, maybe for drywall installation, maybe for fixing of cell joints, maybe doing the leveling work at night time. Next slide. Digital level. So this is also one of the important form of level which today we are using for leveling work. So this bar-coded pattern is converted into elevation and distance values using digital image matching procedure within the instrument. So in case of this digital level, we can say there is a small computer, and with the help of this particular small computer or microprocessor, whatever the stops, coded stops which we are citing from different distances, directly these coded readings are get displayed in the we can say memory of this particular digital level, and all the readings are stored, and whatever the stored readings are there, that stored reading can be used by the computer for finding out the elevations of different points, or from that particular readings directly we can plot the contour map for that particular area. Next slide, please. Different components of this digital level. There are two main components. One is hardware, that is digital level and the leveling staff, and another one is the software. So just like a computer, there is a hardware and software, and with the help of this particular hardware and software, digital level works. Next slide, please. Next slide. Advantages of digital level. Correction of collimation error. So if due to the unadjustment of the line of sight, whatever the errors which occurred in the measured reading, that can be automatically, we can say, corrected by the auto level. Then whatever the human errors occurs while observing the staff reading, that errors can be minimized in case of digital level. Then this digital level is user friendly, means it is easy to read, the display are proper, and the result can be saved automatically. Then whatever the earth correction is there, that earth correction can be automatically applied to the observed reading in case of digital level. Next one, measurement of different reading is consistent and precise. Then whatever the data which we are doing with the help of digital survey, that automatically gets stored in the memory of the digital level, hence there is not a necessity of field book. Then whatever the leveling work with digital level is there, it is fast, economical, resulting in saving in time. Next slide, please. Next one is the electronic distance meter, but this electronic distance meter and other forms of distance meter will be delivered by the next author. So I will not deliver this presentation. So this is all about my presentation, that is revision of surveying and the different types of levels which are used for leveling purpose. So last slide, please, sir. Last slide.
सिमरन लास्ट स्लाइड के हाँ.
Last slide, please. So this is from my side. I am thankful to the organizers of this particular event for giving me opportunity to deliver the lecture on this revision of surveying. Thank you one and all. So if there are any queries, please.
Thank you, sir. Due to time constraint, we move on to the end of the session. On behalf of our institute, I mention my words of thanks to Jadhav sir for giving us their valuable time and share the concepts and introduce various modern leveling instruments. Thank you, sir. Have a nice day.
Once again, thank you for the organizers for giving me opportunity to deliver. Thank you.
Thank you, sir. An announcement is that all participants are requested to join the next online session after half an hour, sharply 2:30 p.m. Thank you.
Thank you, Tapekar sir.
Thank you, sir. Thank you.
Can I leave now?
Yes, yes, sir.
Okay. Thank you.
Thank you. Thank you, all of you, all participants.